In this video on optimizing imagery for the web, I'll talk about the varying file formats that you can use to compress your image files for web delivery. Obviously, I can't actually save a PSD and put it into a website. It wouldn't work within a web browser. Web browsers only display particular file types for the web, such as JPEGs, PNGs, GIFs, or GIFs, SVGs, and some of the newer file formats such as WebP. Let's talk about these file formats and which one might be appropriate for your images. On the class website, I have a handy chart for taking a look at the varying formats for optimizing web graphics, what those formats are generally best for, and also what to be aware of when you're using different formats. So let's talk first about the GIF file format, or the GIF file format, depending on who's talking about it, and that stands for the graphic interchange format. Now, GIF reduces file size by reducing the number of colors on the web. So it actually has a max number of colors of 256 colors, which is also 8-bit color. And that means that you can store all the colors within a single byte for a GIF image. It's great for images that have fewer colors to begin with and hard lines and edges because it has lossless compression. And you've got to be aware, though, that it will create image posterization effects that might degrade your image quality. Returning to Photoshop, let's take a look at an image that has quite a bit of color and actually not a whole lot of hard lines and edges to it either, and explore the GIF file format as a way of saving this versus, for example, the JPEG file format. So to do that, I'm going to use the File, Export, Save for Web feature within Photoshop. And let's switch this over to the GIF file format. When we do that, you'll notice that it generates a color table, and GIF functions to reduce the file size by reducing the number of colors within an image. And that's going to be to 256 colors or less, or 8-bit color or less. By reducing the number of colors, we can actually reduce the number of zeros and ones that go into creating the actual image file in computer code. And so you can see that this image actually is 141K in this particular case, using 256 colors based on the color table that we're seeing. And if we reduce the colors further, we'll have a file size saving. So let's say I go down to 32 colors, I have less color, and you'll notice that it's down to 81K right there, less file size. But we're also starting to really see some posterization effects. And if I zoom in on this, not quite that much, but if we zoom in on this, you can see what it's doing. It's actually creating some posterizing effects. Now, it's lossless compression, so it actually saves every single pixel, but particularly here where we have shades, it might have these dithering effects, and we'll also have these just general posterization effects. That increases as we have less colors in the image. We'll get more and more posterization and really some degradation in the overall color, but you'll notice that we have reduced file size at the same time. The more that we can reduce the number of colors, the less file size. We could bring it down to either an on or off color, which is called 1-bit color. It's either one color or the other. It's like true or false, whether it's there. And that reduces the file size all the way down to 15K in that particular case. But certainly we're losing quality on this particular image. A better solution for this image is not to throw away so much color, but the file size is actually a little bit large at 141. So if I switch this over to the JPEG format, which generally will do better with photographic imagery, you can see that at a quality of 80, which is actually very, very good, I have a file size savings all the way down to 93. It outperforms the GIF in this particular case, and I could even do better by taking the quality slider down, and I might not see that I'm having any loss of quality, and I can bring this down all the way down to 61, for example, at a quality of about 65 in this particular case. Now, when we're optimizing imagery, what we're really doing is a dance between the file size and our image quality. The more that we optimize, for example, if I bring the quality all the way down to 0, I have a much smaller file size, but I'm losing image quality. I'm starting to get compression artifacts within this particular image. And that will happen with JPEG images because they have lossy compression. So that means that we're going to be throwing away or chunking pixels together as we compress this particular image. I want to try to achieve the highest quality image I can at the lowest file size I can. And there's no magic bullet or magic answer to what that might be. It really depends on the context for your imagery. So if I'm featuring the wonderful images of a professional photographer, I'll probably err on the side of having better quality images and not worry quite so much about the file size, particularly if that photographer is in urban markets, for example, and most of the people in that market might be viewing that on a broadband cable connection, high-speed connection, then I'm a little less worried about file size as well. But maybe if I'm creating an e-commerce site that's going to be viewed internationally and I'm really kind of concerned about download times, I'll probably use smaller imagery and optimize those imagery a little bit further because it wasn't so much about the quality of the image as displaying a product or whatnot, but the file size is going to be really important so that those download times don't discourage buyers from waiting to see the product and being able to buy it, right? So there's no magic number in terms of the number of K for an image. You're always trying to do that dance between quality and file size. And that's what image optimization really is about. So in this particular case, the JPEG was the better choice. I could achieve a high quality image at a lower file size than I could with the best quality GIF that I could get. I have a double the file size basically than the JPEG that I was going to select. So in this case, I'm going to go ahead and select JPEG as my saving option. Now, a different image might actually work differently. Let's say I go over to this logo format and we take a look at that particular image. Now GIF might be a reasonable file format for saving this particular image. If I go to save, this has fewer colors overall, so I don't need a large color table, and it really has like hard lines and edges, which sometimes JPEGs don't do as well with. So we'll take a look at that. So in this particular case, let's say I had an 80 quality JPEG. You could see that my file size is 8K. That's really pretty good. But if I switch this over to a GIF image with 256 colors, it's actually 2K, 2.3. Quite a bit of savings. And because there's very few colors in this image anyway, I don't even need to use all 256 that I have available. It really reduces the file size by reducing the color palette in this case. And so for a graphic like this, with fewer colors anyway, hard lines and edges, GIF would be a great file format to use. It's compatible across all the browsers, and we're getting a very small file size. If I switch back to JPEG just to do some further comparison here, I might be able to reduce the file size by reducing the actual quality, but we'll start to see compression artifacts, right? So I can't actually ever get this as low as the, really as low as the GIF was. I can bring it all the way to 0. And the truth is, and it's maybe a little hard to see, but I'm actually getting some compression artifact in here. These are all these little extra things there. Those are compression artifacts. And so I'm really losing some quality on this image that I would not have gotten with the GIF. And that's because JPEGs compress by often throwing away pixels. They'll chunk pixels together, and therefore I'm losing some file size. If we look at the GIF, it's lossless compression, meaning that I have every pixel represented in this particular image, and we're doing a lot better in terms of file size. This is a good use case for the GIF choice for our image. And I'd hit save to save that out. I'm going to return back, however, to our other image that we were working with here. And let's explore the JPEG file format just a little bit more. So I'm going to go ahead and choose Save for Web once again. One of the things that the Save for Web feature does is allow you to have multiple images at the same time, and you can compare the file size versus varying qualities, right? So I could see file size at 80 quality, 92, file size at 22, at 20 quality gives me 22, and I could look at the image quality in comparison between those two. So sometimes I like to put multiple images up at once. I'm going to just choose the Optimize tab. We can compare that to the original here as well. So we can play around with this quality slider, and I want to bring it all the way down to 0 to show sort of how JPEGs function to compress imagery. Now, it's what's called lossy compression, and that's because JPEGs throw away pixel information and they'll chunk that information. When we really zoom in, you can see some of the chunks that are happening. And one way that you can do compression is to find an area of color, right? And where does that color start? Where does it end? Maybe create a gradient in between that block. And you can really see these blocks at 0 quality. These are called compression artifacts that would, be a part of that image. And sometimes they're a little bit hard to see, but we can see that it just looks a little bit funky. I don't like to leave a lot of artifact in my image, and this looks much better when we're not, when we're not really overdoing our JPEG. But of course, the file size is a lot greater if we're at 100 quality. I find that I could bring these quality sliders down at least to 80 without really having a noticeable difference in image quality loss, and significantly reduce the file size. I almost never will save an image for the web at 100 quality. It seems pointless in some ways. If I was, wanting to print the image, I'd probably want to keep the best quality possible, but putting it onto the web and optimizing it, I could save a ton of file size with almost no noticeable drop in quality. So I'm often doing that, and sometimes, a good range here might be, there's no magic range, right? But I find that I could, often get away with something like 68, still really have a good looking image, and get a lot less file size potentially with that image. Ironically, 68 is 68K in this particular case, but that's just random in terms of that. I rarely will save things way down where I actually am embedding quite a bit of compression artifact. I tend to err on the side of a little bit better quality images personally, and so with broadband cable modems, a little less worried about having a little bit of a larger image, but I'm still really trying to optimize my graphics. Okay, so you're going to want to choose a quality slider that's appropriate for your particular image, and you can take a look at what that looks like and save that out. However, JPEGs are not going to do as well on real vector-based graphics, and graphics that have transparency on them aren't available in JPEG. So if I try to save this for the web, you'll notice that it fills in that background with a matte color. You can change what that matte color might be, like I could change it to black or whatever, but I can't maintain transparency with my JPEG image. The other thing is that the overall file size here, you'll notice 21K, not terrible, but if I was to switch this to a GIF, for example, I could get this down to 5K, for example. GIF images do support transparency, but you have to be careful about transparency on the edges. Look what it's doing, filling in that matte edge. It gives you these kind of highlight edges. Now I could say that I don't want a matte edge, but nevertheless, the very edge might get a little bit rough or whatever. Typically it will fill in that edge with a little bit of white, and you end up with these highlighting effects when you're working with a GIF for saving on transparency. This is where PNG really is superior. And if I switch this image to a PNG image, you'll notice that I can save this out with a high quality transparency, partial transparency on the edge. PNG 24s will give you basically 8-bit transparency effect. So you can get a partial transparency on the edge, whereas GIFs only have an all or nothing transparency, or 1-bit. And so you'll notice that it fills in and we don't get that partial transparency. So GIF images, PNG images are great for saving graphics in particular with transparency. Anytime you need that transparent background, you're going to want to use a PNG image. Let's return to this other colorful image and take a look at saving that in PNG and what the advantage might be to that. So you'll notice that if I save this as a JPEG, around 93K, and if I switch this over to the PNG, I actually get a good quality image as well, but we only have, it's a larger file size, right? 376K, quite a bit larger in file size than the JPEG. The advantage of this is simply that PNGs give you lossless compression. And that means that I could resave a PNG over and over and over again. It's not throwing away any of the pixels the way that the JPEG would. So if I save this JPEG and then I open it again and I save it again as a JPEG, it starts to degrade in quality each time that I do that. And so a PNG gives you that lossless compression, meaning it's not chunking your pixels, it's not throwing away any pixels. It gives you some compression, but without ruining the image. Like I could resave a PNG as many times as I want over and over again. A JPEG is kind of a one-time affair. Once you have your JPEG, you can save it out, but you wouldn't want to resave that JPEG multiple times. You'd be losing quality every time. So returning back to our chart here, just a couple pieces of terminology as well. You'll see that JPEG stands for the Joint Photographic Experts Group. If you're ever quizzed in trivia about it, PNG stands for Portable Network Graphics. We'll talk about SVGs next, and those are scalable vector graphics. There's also other formats that are emerging on the web, such as the WebP format supported by Google, which claims to give you about a 26% file size savings compared to some of these other formats without a quality loss, but it depends on the image. It hasn't been fully widely adopted yet, but the browsers are starting to adopt that as well. There's also what's called the animated PNG images that are out there, and some other high quality JPEGs. We might see some emerging formats on the web, but the common ones now are the GIF, JPEG, PNG, and SVG formats, and each of them have their particular use cases. So returning back to the chart, we talked about how GIFs are great for graphics with fewer colors. They reduce the number of colors in an image, whereas a JPEG and potentially a PNG do not. Giving us 24-bit color or millions of colors, right? But JPEGs might leave compression artifacts that degrade our quality depending on how we save them, and resave JPEGs lose quality each time they're saved. Whereas PNGs have lossless compression. The file size is a little bit bigger, higher than JPEG, right? But they're great when we have images with transparency. That's what we'd want to use. So coming back to another image here, let's say I actually had an image such as this one that had a transparent background. How do I save this? Well, the only option really is to use the PNG. So if we come over here and we look at the JPEG, it's going to fill in those transparent pixels with some kind of matte color. A GIF would give us transparency, but it always is going to fill in the edges, and you might get highlights depending on what kind of background you're on. So if I fill in the edges with black, for example, we can really see where those highlights would be. White is less noticeable unless I put that on a dark background, in which case those white highlights would show up. What we want is the partial transparency on the edge that we're given with the PNG. And the file size is a little bit bigger, but it'll allow me to have an image with that transparent background, such as this one. Returning back to this logo graphic, I had mentioned before that GIF was a great file format for that. Another great format would actually be the PNG as well. You'll notice that if we go to PNG, the file size is pretty good, 3.9K. Not quite as good as GIF, but PNG does have an 8-bit format that reduces the number of colors in the image, and that gives you a really good file size as well. So this image, PNG is a little bit more modern. It gives you some of the benefits of GIF, some of the benefits of JPEG. It can be a little bit higher in file size, but a reasonable way to save this as well would be as a PNG image. You'll notice that it's only 2.05K. The GIF version of that is actually a little bit larger, and so PNG is doing just a little bit better in this particular case, and it works well with our graphics, hard lines and edges, that kind of thing. If we want to reduce the number of colors, we have that option called PNG 8, 8-bit color 256 or less, or if we don't want to reduce the color palette, PNG 24 would have the full robust color palette. Now, if I'm saving an image like this, that's a logo, I might want to consider a new modern format such as SVG. Now, I put this image together inside of Photoshop, and I used the vector shapes that are available in Photoshop as well as some text. And it's just a sample logo. One of the file formats that I could save this image out as would be the SVG, or Scalable Vector Graphic format. And let's take a look at doing that. I can go to Export, and one of my options, I'm going to go to the Export As, which is, Photoshop has a few different ways to get your images out, and this is one of them. But one of my options is actually to save this out as an SVG image. You can see doing that might be the smallest file size for this, 637 bytes. That's not even 1K, whereas a PNG, for example, is going to be 9.6K with the transparency on there, right? A JPEG or a GIF, 5.4, a little bit better than the PNG in that particular case, and a JPEG, sort of the worst, 36K in this case, plus I don't get any of my transparency. You'll see the winner in terms of file size here is the Scalable Vector Graphic. So if you're working with vectors, and not just pixel-based graphics, you could use this. Anything that you might build in Illustrator, for example, or with the vector tools inside of Photoshop, we could use Scalable Vector Graphics. That's not going to work with a photographic image. Really, a photograph, you probably want a JPEG, but these vector-based artwork, Scalable Vector Graphics are awesome. One, the file size is pretty small for this particular image. The other is that this will scale to any size. So you'll notice that if I save this out as a SVG, let's go ahead and export that as SVG, and I save this image out. I'll call it Sample Logo SVG, and then I'll open that image inside of a web browser. Here's the image in a web browser, and it looks nice and clean. And one of the things you'll notice about it is if I can actually scale this image. So I'm going to zoom way in, and I don't lose any quality on that image. That's the great thing about vectors, is that you can scale them to any size. They're naturally responsive in that sense that we could scale them however we want, maintaining perfect quality on that image. You can actually take a look at the vector file. I have it open here inside of Dreamweaver, and I can look at the code that comprises this SVG file. And it's actually just being drawn with code. And so that's pretty powerful. It's partly why the file size is so small, less than a K, in order to have that particular file. And you'll notice that it has some details here. If I wanted to insert that into a web page, I could. I've opened a web page file here, and I'll just use the tool Insert Image, for example, in order to insert that sample SVG image. And so I'll find that one that I just created, insert it into this file. I'll save this particular web page, which I did here as test SVG, and we could take a look at what that would look like in a web browser as well. There it is. By default, it will come out here at the native size, but we would be able to add some styling to this. I'm just going to go ahead and add the style tag and say that our image is going to be, for example, let's make the image width, I'm just going to say 100% of our screen. And when I do that, we save that out, and I return back to that same browser window here, you'll see that it will scale that to fill whatever our screen size is. And so if I change my screen size, that will adapt and maintain great quality. So in terms of our formats for optimizing graphics, we have a lot of choices, and you want to use the best format for your situation. And in this particular case, you'll be choosing between GIF, JPEG, PNG, and SVG. Most photographs, you're going to do best with JPEG, unless you needed to resave it multiple times for some reason and you need that lossless compression. Most images with transparency, you're going to want to work with PNG. Images that are kind of graphic with fewer hard lines and colors and fewer colors, GIF is one of the options for us. And if we needed animation, GIF is really one of the only formats that supports animation. So that would be a benefit if we needed animated images. JPEG, for example, does not support that, and neither does PNG, but there is a format that might be coming out called APNG that allows animation in PNGs. SVG is awesome if you're working with vector shapes, so those geometric shapes that can scale to any size. You're going to have a flat 2D style usually with those types of vectors. Really complex shapes, you have trouble optimizing potentially, but most logos and things like that, you could work with SVG. And it's got pretty good browser support these days. It's a newer format, but in modern browsers, it totally works. And you can even animate SVGs via CSS. So it's possible, because it's code-based, we could change the code and potentially be able to animate our SVG graphics as well. Okay, so that is the rundown of optimizing graphics for the web. Completing the last video in the series, and really one of the most important ones, of using the right file format. But consider making sure that every image that you put into your web pages, think about reducing the physical size to the actual size that you need, simplifying the image potentially so that there's not distracting elements and so that you can optimize it a little bit better, and also compressing it using the appropriate file format. Happy image optimizing.